All right, guys, this is going to be our third section of trigonometry, and this one is going to be focusing on the sine function. So we're going to learn these law of sines. So when do we really use law of sines, okay? The law of sines allows you to find the area of a triangle and allows you to find the missing side or an angle of any type of triangle, okay? Using this trig, mainly the sine function. If you noticed on the last two sections, we only worked with right triangles. Now we're going to work with nothing but, or really any type of triangle. Okay, so let's do the investigation associated to the area of a triangle. So you did technically already learn how to find the area of a triangle, but we had to divide it into where we have a height and a base. So you can see that in both of these pictures. So we're going to find the area of these, and then we're going to make a generalization as to how we can quickly find the area of a triangle. Okay, so let me get my pen, and we're going to find the area of both of these. So in order to find the area of this first one, this is going to be my base, and then that's my height, which is already labeled, which I don't have. So I have to find it using trig. This is the opposite, and this is the hypotenuse. So O and H come from so. Remember, so, the, toa. So sine is what I want to write down. So I'm going to write sine of 55 degrees equals H over 29. Okay, when the variable's on top, I multiply those two. So H is going to equal whatever 29 times sine of 55 is. So 29 times sine of 55. So let me get my calculator. Make sure your calculator is in degree mode. Okay, it should not say rad for radian. So 29 times 55 sine equals. So the height for this triangle over here on the left is about 23.755. Okay, so that's the height. So again, this is from 29 times sine of 55. And then what am I going to do with this number? Okay, so I'm going to take the height, which is 23.755, and I'm going to times it by the base, which is 33. And then don't forget, you're going to divide by 2. Okay, and so I have that number in my calculator. I'm going to times it by 33 equals, and I'm going to divide by 2. So the area of this triangle is 391.964 centimeters squared. Okay, so this is area. Okay, so think about the repetitive thing that we're going to do here in this second one. Okay, and you're going to realize, oh, this is kind of the same thing. So over here I have the height. Goes a little bit different, okay, but you saw that in previous problems from our other two sections. So I'm going to solve for the height, okay, because this is my base and that's my height. And I'm going to use the 72, which is opposite, and this one's hypotenuse. What do you know? That's the same thing that we had over here. This one was opposite, and this is the hypotenuse. So we're notice, again, what's repetitive? We're using the sine function again. So we're going to say sine of 72 degrees equals opposite over hypotenuse. Okay, to solve for that, we're going to multiply 21 times sine of 72. And then H is going to equal, so don't forget to use your calculator and make sure it's in degree mode. It should still be degree mode. Times sine equals. Okay, so 21 times 72 sine equals about 19.972. All right, so that's your height. And so now we're going to use our area formula. And so remember, we're going to take the height, because it's base times height divided by 2. So we can take the height, which is 19.972, times the base, which is 38.5, and then don't forget to divide it by 2. Okay, so I have that number in my calculator still, so I'm just going to hit times 38.5 equals divided by 2, and then the area of this is going to equal about 384.465, and this is in centimeters squared again. So what was real repetitive right here? You'll notice that, and let me get my highlighter so I can point some things out. You'll notice that to get the height, we had to multiply 29 times sine of 55. So you'll notice 25 is this side, and then times sine of 55. Over here, we did 21 times sine of 72. Okay, so 21 is right here, times that 72. So kind of the same pattern there. Then that right there equals the height. And then what did we do with that whole thing? Now remember, let me get a different colored pen here. Let's get green. Now remember, this whole thing is equal to that. Same thing here. This whole thing is equal to that number. So to keep things very accurate, we can use this highlighted multiplication, which is 21 times sine of 72, and over here 29 times sine of 55. That is going to be equal to the height, which what did we multiply that by? We then multiplied that by 33, which is this side, and over here we multiplied that number by 38.5, which is this side. And then what did we do on both of them? We divided it by 2 on both of them. So that's what's repetitive over and over again. So we just basically are taking this number, the yellow side, times sine of the angle. Notice it's in between two, y'all. Look at that pattern. This is in the form of side, angle, side. Side, angle, side. Was this the same thing? Look, side, angle, side. So those are in that form of side, angle, side. So this is the pattern. How can we generalize this for this problem right here? It says find the area of this triangle, and you don't have really necessarily any numbers, but think about what we just did a second ago, okay? We don't want to take the time to draw the height and use that function, okay? Remember, this is the form of side, angle, side. So what did we do? We multiplied, remember, one of these sides by sine of angle C. And then we multiplied it times A, which I'm just going to put it on this side to make it look simpler. A times B times sine of C. And what did we do both times? We divided it by 2. Okay, so the area of a triangle, whenever you're given two sides and the included angle, okay, so keep that in mind. You're given A and B, and you're given angle C, which is the angle between the included angle. Then you're going to do, you're going to do A times B times the sine of C, which remember that's an angle, and then you're going to divide it by 2. Another way to write it is 1/2 times A times B times sine of C. Okay, now don't get caught up on just using A, B, and C, those letters. Remember, because they're going to just basically be numbers, so they can be anywhere on the triangles, but it has to be in the form of side, angle, side. You have two sides and the included angle, and you can easily use this formula to find the area. You don't have to do every single step like we did earlier up here. So it's real simple to just use this formula. Okay, we'll practice that in a minute. Okay, so now let's talk about the law of sines. Okay, so the law of sines is something different. It's not necessarily associated to area. So let's follow this little investigation with the steps and then you'll figure it out. So it says find H, okay, in terms of A and the sine of an angle. Okay, so find H in terms of A. So here's A and the sine of an angle. So think about it. If this is H and this is A, what would be, if we're working with this and this, what would be the angle in terms of sine? Okay, well, this can be the opposite of this angle, and this can be the hypotenuse. So remember, opposite and hypotenuse is sine, and that's exactly what they're telling us. So let's solve for H. So it says find H. So let's write the equation out first. So sine of B equals opposite over hypotenuse. Now it says to solve for H in terms of A. Well, to get H by itself, I need to get rid of the A. So how do you get rid of A? You multiply both sides by A to cancel it here and over here. So H is equal to A times sine of B. Okay, let's go to step 2. So now it says find H in terms of B. Okay, so let's look at this other triangle on this side. So here's B, here's H. Well, if you focus on angle A, this is opposite and this is the hypotenuse. Okay, so this is opposite and that's hypotenuse. So let's write it out. So we're going to say sine of angle A equals H over B. So just like we did up here, we want to solve for H. So we're going to multiply both sides by B. Whatever you do to one side, you must do to the other. So here we have H equals B times sine of A. Okay, so think about this for a second. Okay, I'm going to box both of them. If H is equal to A times sine of B and H is equal to B times sine of A, don't you think that this is equal to this since both of them are equivalent to H? That is true. So in step 3, it says use algebra to show what A over sine of A is equal to, okay? So let's set these equal over here. So we're going to say A times sine of B, which is the one up here, equals B times sine of A. Now remember, it says make a fraction A over sine of A. So you can easily do that by dividing by sine of A. Whatever you do to one side, you must do to the other. Divide by sine of A. Well, don't you think you can do that? So that way we can get A by itself. Divide by sine of B. Cancels out on this side. Divide by sine of B. So here it is. Let me get my highlighter. A over sine of A is equal to what? B over sine of B, because remember, those canceled out. So let's write that down over here on the left. What is A over sine of A equal to? It's equal to B over sine of B. Okay? So if A over sine of A is equal to B over sine of B, this is the law of sines. A over sine of A equals B over sine of B. Now we left one off, the C. Okay, if A over sine of A is equal to B over sine of B, okay, and of course you can continue to solve for it using C, we would have to use a different hypotenuse. You'll realize that C must also be equal to, B over sine of B is also equal to C over sine of angle C. Now remember, these are little a, little b, little c. This is capital A, capital B, capital C. These are for the angles. You can put a little degree symbol on there if you're getting a little confused on what is what. Little a is the length of the side, as well as little b as little c. Capital A is the degree measure, okay? And that's the law of sines. So this formula, you do not have to memorize also. That's also on your formula chart. So let's try some example problems over here. So you'll notice it says find the area of this. Now remember what I said to focus on. Think of side, angle, side. So remember the formula kind of goes like this. If this is A and this is B, and that's angle C, all you have to do with that formula is do 1/2 A times B times sine of C. Okay, so do we have a side angle side situation? No, we don't. But is there any way you can solve for this angle? Absolutely. These three angles add up to 180. So let me get my calculator. So 180 minus 150 is 30. So this angle right here is 30 degrees. Now look, here's your side angle side. You can treat this as A, B, and C, like we used in our formula earlier. So here's a quick way to get the area. You're going to do 1/2 times 20.5 times 25 times the sine of 30 degrees. Okay, so let's put that in our calculator because that's all we need to do. You just have to punch all of that into your calculator. And again, this comes from that formula. So I'm going to do 0.5 times 20.5 times 25 times sine of 30. But don't forget, you have to hit 30 sine and then hit equals. So the area of that triangle is 128.125. And this is in centimeters squared. 128.125. All right, so there's an example using the new area formula. See how I didn't even once have to draw the height? Okay, so you don't need to do it that way. Worst case scenario, if you don't know how to use this formula right here, then go ahead and do it the long way. Okay, on this one, think about law of sines, okay? So law of sines, let me go back and review it. So here's law of sines. Actually, maybe I should draw a picture to kind of help you understand it, okay? So this is pertaining to an angle like this, capital A, capital B, capital C. This will be little a, little b, little c, okay? So that basically comes from this triangle right here, but eliminating the height thrown in there. So this formula right here we can use right here. Notice little c is across or opposite of angle C. Little a is a opposite of angle A, and little b is opposite of angle B, okay? So just to reiterate that. So now over here, if I need to find AC, so I'm going to just put an X there to keep it one variable. This is across from this angle right here, and notice it's using A, B, and C again. So actually, let's not call it X, let's call it little b, since they have all of these as A, B, and C. This is capital A, which this can be represented as little a. So remember, the formula is little a over sine of A equals little b over sine of angle B. Okay, so now let's just plug in what we know. 350 is going to be on top. Sine of 59 degrees is on bottom. Little b is what I'm trying to solve for. And then sine of 38 goes on the bottom. So how do you solve this type of problem? You cross multiply. I'm going to multiply 350 times sine of 38. So I'm just going to write it down for now, and then I'll use my calculator. 350 times sine of 38, and that's equal to b times sine of 59. Well, how do I get b by itself? Well, if that's times sine of 59, don't you think you can divide by sine of 59? That comes from algebra. And whatever you do to one side, you must do to the other. So that cancels out. So I'm multiplying these two and I'm dividing by this. So let's see what we get. I'm going to use my calculator now. So I'm going to do 350 times 38 sine and hit equals. Okay, so this top number here is about 215.4815. Okay, now don't forget you're dividing that by sine of 59. So since we have that long number in our calculator, let's hit divided by 59 sine, and then don't forget to hit equals. And so that's B, which is equal to 251.388. So AC, which is little b, is 251.388. And this is centimeters that we're using. All right, let's try it again over here. Over here we have 150, 250, and I need to solve for angle C. Okay, so that's what I need to solve for. Now think about it. This is like little a, this is little b. I don't know capital B. So what could we do? Well, can't I use this to solve for B? And then once I have 2 out of the 3 angles, I can subtract that from 180. So let's do that. So I have little a. Remember, I'm going to use this formula right here. So this is 250 over sine of 64 equals 150 over sine of B. So I'm solving for B. So I want to do the same thing. I want to cross multiply this times this. So it's 150 times sine of 64 and that's going to equal 250 times sine of B. We need to get this by itself, so I'm going to divide by 250, divide by 250. All right, so let's use our calculator now. So I'm going to do 150 times 64 sine equals, so this equals 134.819. And don't forget, I still need to divide that by 250, and that's going to equal sine of B. So I have that long number in my calculator. I'm going to leave it there. So I'm going to divide by 250, which equals 0.539276. Remember, that equals sine of B. And how do you solve for an angle? Remember, you learned on our last section, you do the inverse. So you're going to do the inverse of that big number in your calculator. And that's going to equal angle B. So all I'm going to do is hit second, because I want to be using the inverse, and I'm going to press sine inverse. And don't press equals, because then it's going to change the number. So you should have gotten about 32.6 degrees, okay, which we're going to go ahead and round to the whole number. So this is about 33 degrees. So angle B is equal to about 33 degrees. It was 32.6, but we're going to round to the whole number. So now that you know this, which we had to use law of sines, now you can use your 180 rule to figure out C. So 180 minus 64 minus 33. This one up here is 83 degrees. So angle C is 83 degrees. And that's using law of sines. And that is it.